Okay, let's continue. Example 11 on page 329. Now, don't ever say I didn't give you freedom and choices in this class, because you have some. Let's look at example 11. Look what we have here. We have an x term, a variable term on both sides, and we have a constant term on both sides, okay? Ultimately, we need to put the x's on one side and the constants on the other, but it doesn't matter which way we do it. Okay, so let's do it both ways to convince ourselves of that. So in this case, I'll put the x's on the left, so I want it to disappear on the right. So subtract 6x, subtract 6x. 9x minus 6x gives me 3x plus 2 equals negative 10. Subtract 2 from both sides. 3x equals negative 12. And we will divide away that 3, and we'll get x equals negative 4 for the answer. Okay? Now we chose to put the x's on the left. I could just as easily have chosen to put them on the right, and I want to do it that way just this once to demonstrate that it doesn't matter. So it will be your choice, okay? Let's put the x's on the right. So we're going to subtract 9x from both sides. So now I just have the 2 over here. 6x minus 9x is negative 3x minus 10. Add 10 to both sides. 2 plus 10 is 12 equals negative 3x. Divide by negative 3. Divide by negative 3. I get negative 4 equals x in this case, and I get x equals negative 4 in that case, and those two things are, of course, the same. Okay? So it makes no difference, okay? Sometimes one way versus the other may give you less negative signs or something to deal with, but that's really random unless you're able to spot it, okay? You notice we had negatives to deal with in either case, okay? So it really doesn't matter. Just take your pick. 9 times out of 10, I'll put the x's on the left just because that seems to be the most comfortable way to do it, but if it seems advantageous to leave them on the right, I'll leave them on the right. Okay, we'll see what happens. You know, what equations come our way, and we'll decide. Okay, example 12 on page 330. Let's take a gander at that, shall we? Example 12, page 330. What do we have here? We have 2x minus 3 plus 5x equals 8 minus 6x. Alright, so you see we have to do some simplifying on the left, okay, because I've got those like terms I can combine. So we must do that first. So we'll put the 2x and the 5x together. That'll give me a 7x minus 3 equals an 8 minus 6x. Okay, now here we are. We have this choice. I can put the x's on the left, or I can put the x's on the right, and vice versa with the constants. Makes no difference. 9 times out of 10, I'll just put the x's on the left, so I want it to disappear over here. It's a minus 6x, so I add 6x to it. You do the exact same thing to both sides, so that would give me a 13x minus 3 equals 8. Okay. Add 3 to both sides. I'll get a 13x equals 12. 8 plus, 11. Duh. Equals 11. Divide by 3. Divide by 3. I'm going to get x equals 11 thirteenths. Okay? All good? Equation solving isn't that bad. All we're going to do moving forward is we're going to trick them up with more and more clunkiness, more and more order of operations type stuff to do. But at the end of the day, we're going to shuffle across the equal sign and we're going to solve for x. Okay? We may just have some simplifying to do on either side first. Okay, like our next example. Example 13. I got a little 28 all by itself over there. So one side looks nice and pretty, but the other one's got a little bit of stuff to do here. Okay, so I've got 7x minus 3 equals x minus 4. All right? What do we need to do here? We have a parentheses, right? Now, I can't do anything inside the parentheses because the x and the -4 are not like terms. I cannot combine them. Okay, so I'm going to move beyond the parentheses, and I'm going to see here I have a -3 to distribute across. And it's important that we distribute the negative along with the 3. Because when we do this, we're going to drop the parentheses. Okay, now let me make a mistake here. Okay, 28 equals 7x. I'll bring down the minus, and then I'll distribute, and I'll get 3x minus 12. Okay, that's a mistake. I can't bring down the minus unless I'm going to leave the parentheses in there, and I don't want to leave the parentheses in there. I'm trying to simplify and get rid of the parentheses, you see? So it really should have been a -3x, which it still is, a -3x. However, negative times negative, it should have been a positive 12. Okay, so I'm forced to leave the parentheses in. Okay, now it's not a mistake anymore. It's just not as nice as it could be because I still need to distribute that negative across. Okay, so now there we go. So had I just done that originally, take the whole -3x and subtract and distribute the whole thing across, I get myself a -3x and I give myself a positive 12. So I can eliminate this middle step here whereby I have to leave the parentheses in there. I don't want to leave the parentheses in there. I'm trying to clear out those parentheses so I can simplify this. Okay, so if there's a negative there, you must distribute the negative across along with the number. Okay, let's keep rolling. That's an equal sign, not a minus. Equal. 7x minus 3x gives me a 4x plus 12. Okay, you see I only have x's on the right, so it would be crazy for me to move the x's over to the left, right? I really don't have a choice now because there's only an x on the right. I don't want to do anything else except get x equals number, and my x happens to be on the right, so I'm going to leave it there. So I'm going to get rid of the 12. Okay, I'm going to subtract 12 from both sides, and when I do that, what am I going to get? I'm going to get a 16 here equals a 4x. 4x equals 16. Divide by 4. 4 equals x. X equals 4. Okay? All good there? So we might have to do some simplifying on both sides of the equation. Really, this one we only had to simplify one side. Typically speaking, we'll have to do some simplification on both sides in order to fully solve. Okay, it just depends on what's thrown at us. So let's check out example 14 now. Page 331. 6 minus, and then a parentheses. We talked about that. When you have a minus sign in front of a parentheses, what do? It's like distributing a -1 across the parentheses. So that becomes a 6 minus x minus 3 equals 2x. Okay? I can combine the 6 and the minus 3 to give myself a 3 minus x equals 2x. See, I moved that -3 over there next to the 6, and I said 6 minus 3, and I got a 3. Okay? No different than if I called that plus a -3. 6 plus a -3 is a positive 3. Okay, here I am. Again now, I really don't have the choice. If I were to move this 2x over to the left, now everything's on the left and nothing's on the right. That's no good. I want to have the constant terms on one side and the variable terms on the other, so I'm going to put my x's on the right this time. It doesn't make sense to do anything else. So now I've got 3 equals 3x. Divide by that coefficient. Remember what this is doing here. It's turning into a 1x. Okay, I'll write the 1 this time. 1x equals 1. X equals 1. All right, all good? Okay, I like it. I like it a lot. Let's see what our next problem has to say for itself. Example 15. We've got an A and a B here. Part A, fractional coefficient. Now let me drive a point home here. 5x over 8 equals 30. That's no different than if I had written this. 5/8 x equals 30. Is everybody comfortable with that? Only the numerator is being multiplied by x, but it's quite common to kind of write x next to the whole fraction. Okay? It's also quite common to just stick the x up there in the numerator. Okay? If you have your book in front of you and you look at part B of this same example, here, let me pull the book over. Here it's written 5x over 8 with the x up there in the numerator, but over here in part B you see this, they switch to a z, but it's next to the 1/2. Okay, instead of being up there in the numerator, but those two things are equivalent. You can either write it next to the whole fraction or stick it up in the numerator, but it's only multiplied by the numerator. It is not multiplied by the denominator. Okay? Alright, so either way we think about it, in order to undo this problem, I've got 5/8 times x. I want to divide by 5/8, but we talked about this already. If we multiply by the reciprocal, 8/5 instead, it's a little bit cleaner looking. So both sides by 8/5. Well, what happens here? The 8's cancel, the 5's cancel, right? I mean, I'm really looking at a 40 divided by 40 times x. And over here, I'm really looking at a 30 over 1 times 8 over 5. All right? 40 over 40, that's just 1. So that's just x. And you know there's some clever canceling we can do here, right? Because at least inside the 30, there's a 5 hidden in there. So maybe we don't want to actually multiply it, but it's not the end of the world if we did, right? If we took 30 times 8, we're going to get 240 divided by 5, and then if you bust out the old calculator, it's easy enough to do. I don't have my calculator sitting here, but if we did it the other way, we'd say, you know, that 30 is really 6 times 5, and then I had times 8, and then divided by 5, so the 5's cancel. So it's really just going to be a 48. Okay? All good there? X equals 48. A little more proper way to write it would be on its own fresh line instead of doing what I just did there. It's always kind of proper to just say x equals x equals x equals all the way down the line instead of continuing along to the right. Okay, now part B of example 15. I want to work it a couple different ways. All right, 1/2 z, so we're switching to z for laughs, equals 1/4 plus 1/12 plus 1/3. Actually, yeah, this one doesn't really lend itself to be working the other way, but we'll get to that with fractional equations, okay? What do we got here? We got a bunch of stuff on the right that we first must consolidate. So now we're just going back to, you know, fraction school here. We got to remember how to add all these fractions. We need a common denominator. So I need to multiply that one by 4 over 4, that one by 3 over 3. The common denominator is 12, right? 1/2 z equals, that's really 3/12 plus 1/12 plus 4/12, right? So it's really 1/2 z equals 8/12. Okay, all agree? Well, at this stage, we could either reduce that 8/12 now, or we could kind of wait till the end and then reduce. It really doesn't matter, but it might save us a little legwork if we did a reduction now, so maybe we'll go ahead and do that right now. How do I reduce 8 over 12? You know, if you ever forget, just pull off to the side here and factor. You factor and you cancel. Oops, 4 times 2 is 8. 4 times 3 is 12. Those 4's go away. So it's really 2/3. 1/2 z equals 2/3. Fractional coefficient, I'm going to multiply by the reciprocal of that fraction. So that becomes a 2 over 2z, which is just a z. And this becomes a 4 over 3. Okay, so z equals 4/3. Alrighty. Decimal coefficients, decimal problems. Again, when we get to more complicated fraction and decimal problems, there is kind of a little, I won't call it a trick, but a little technique to clear those fractions and decimals out of there. These problems here don't really require it because they're a little more straightforward. With the calculator, it's no big deal, right? We're just going to divide by this coefficient in front of x, and as we can see, this is a nice division anyway. It's going to be just 1/2 or 0.5. Okay. And we just look through what we've got here. Couple examples. Example 16 on page 322. Let me get you there so you can see it. A horticulturist marks off a 32-meter wide rectangular nursery plot with 158 meter of fencing. Because the plants must be properly spaced, she needs to know the length of the plot. Find the length in meters. Okay. Well, what do we know here? We know that our width is 32 meters, and we know how much fencing we have. So we know our perimeter, and we know our width. Okay, so this is a classic problem like we've done before, but we've got an unknown kind of in the middle of the problem that we didn't have, when we previously worked with this formula. So the formula for perimeter is twice the length plus twice the width. And if we kind of write it a little more consolidated like that, it's L plus W in parentheses times 2. We could distribute that 2 across. Well, we were told something. We were told that the width is 32 meters, okay? And we were told that we have 158 meters of fencing, so that would be my total around. That's all I have to work with. What length am I going to be able to use here, okay? So if we put the information in there, 158 equals 2 parentheses L plus W. L I don't know, but W I do know. Okay, L plus 32. And now we solve for L. Okay, we know how to do this. I've got a little cleaning up to do on the left here. I'm going to distribute my 2, and I'm going to get a 2L plus 64, right? I've got an L over there on the right side of the equation, no L's on the left, so I need to get all my constants over there to the left. So I'm going to subtract 64 from both sides, and I'm going to have 94 equals 2L. My last step will be divide by that number in front of L, that coefficient, so I'm going to divide by 2 on both sides. So I'm going to get L equals 47. Okay? All good? All right, good deal. Let's look at the next one. Example 17. A machine part weighs 2.7 kilograms and is to be shipped in a carton weighing X kilograms. If the total weight of 3 packaged machine parts is 9.3 kilograms, how much does the carton weigh? Okay? Does each carton weigh? So I'm going to have these parts that are going to be each individually wrapped in their little cartons. Okay, now we're going to ship it out. So I'm going to have 3 times some weight. 3 times my individual weight, let's call it. Equals my total weight of 9.3. I think we're talking kilograms, right? Yeah, kilograms. So I've got 3 of them. Each one has a certain amount of individual weight. And I'm going to have 9.3 altogether. Well, what comprises this individual weight? I know I've got 3 of them. Well, I've got 3 of the actual parts plus the shipping boxes. So the parts plus the box equals 9.3 kilograms, right? 3 of them. Well, how much does the part weigh? That much we were told, 2.7 kilograms. The box is the unknown, so, let's be fancy and let's use the letter B for box. The book probably uses X, right? But we'll be cool and use a B. 2.7 kilograms plus B equals 3 times all that equals 9.3. So let's go ahead and solve this now with our algebra techniques. I need to distribute my 3 across. Okay, so what are we going to get here? 2.7 times 3 is going to give me 8.1. I'm going to drop the kilograms for a minute here. All these units are going to be in kilograms, okay? Plus 3 times b equals 9.3. Okay, how do I solve this? I get all my constants on one side, my variables on the other. So I'm going to subtract the 8.1 from both sides. I'm going to get 3b equals, that'll be 1.2. Last step is I'm going to divide by that 3, so I'm going to get b equals 1.2 divided by 3, 0.4. And again, the unit was kilogram. That's the weight of each box, or each, I guess they call them cartons, so C would have been more appropriate, but whatever. Okay, that's the idea. Alright, that concludes section 7.2, so the next video we will pick up 7.3.